mentioned before that it's really important to know how to divide polynomials because it will help us figure out what the factors of it are. And therefore we can find the zeros. We talked about one method of division, long division. There's another method of division out there called synthetic division, and you might think about what that word synthetic means. I'm wearing synthetics right now. It means it's fake. It's probably, some sort of polyester blend, I don't know. But synthetic means fake. So this is kind of like fake division. It's kind of like a shortcut division for division. And you'll find that it's much, much, much faster than long division. So you'll probably like it a little bit better. But it does come with a big asterisk. We can only use synthetic division on polynomials if our divisor, if what we're dividing by, is of the form x minus a. So the last example that we did with long division, we divided by, I think it was like 2x minus 6 or something. That was not of the form x minus a. So we have to make sure our divisor has a coefficient of 1, a lead coefficient of 1, and that it's linear. Otherwise, we can't use synthetic division, at least the kind that I'm going to show you. So let's look at an example. Let's divide 3x to the 4th minus 7x cubed plus x plus 8. And let's divide that by x minus 4. Alright, so here's the setup. We would look at what that a value is, and we would put that up in the corner. So x minus 4, we're going to put a 4 up in the corner. That's our a. Next we're going to write down the coefficients of our dividend. 3, negative 7. You might think the next coefficient is 1, but notice, look at the powers of x. X to the 4th, x cubed, x, and then x to the 0. We're missing our quadratic term. We can't just forget about it. We need a placeholder there. So that 0 is for 0x squared, plus 1x plus 8. These are the coefficients of our dividend. And again, that 0 is the placeholder for our quadratic term because its coefficient was 0. You could think of that as just a plus 0x squared in there. Alright, and then I draw a little line a little bit further down. Here's our synthetic division process. Always bring down that first coefficient. You would then multiply 4 times 3. We would get 12, and you write that underneath the next coefficient. We would then add. That's why this is a little bit different from long division. In long division, we were continually subtracting. Here we're adding. Negative 7 plus 12 is 5. Now we repeat that process over and over until we get to the end. Multiply and then add. 5 times 4 is 20. We would then add 0 plus 20 is 20. Repeat. 20 times 4 is 80. We can then add, and we will get 81. 81 times 4 is 324. And then we can add, and we'll get 332. And we're done. There's no more numbers to work with. What the heck do these numbers now represent? Well, these are the coefficients of our quotient. How do I know the degree of our quotient? Well, we took a quartic divided by a linear. Our quotient is going to be a cubic. Our quotient is always 1 degree less than our dividend if you're dividing by a linear. So let's write that down. Coefficients of quotient, 1 degree less than dividend. So our dividend was a quartic. This must be a cubic. So, but we have 1, 2, 3, 4, 5 numbers here. So let's see, 3x cubed, that must be our first coefficient, plus 5x squared, plus 20x, plus 81. What the heck is the 332? It's the remainder. That last number there is our remainder. Why do we care about the remainder? Well, don't forget, if the remainder is 0, then we knew that our divisor was actually a factor of our dividend. So that's why we care about that last number, and we do need to write that down. So that's synthetic division. It's pretty quick. Let's try to answer this question. Is x plus 5 a factor of x cubed plus 11x squared plus 35x plus 25? How do I know if something's a factor? Well, we'd want to divide and then look at the remainder. If the remainder is 0, then yes, it was a factor. Wait a second, I thought we could only use synthetic division if we're dividing by x minus a. We're going to have to divide by x plus 5. Well, that's the same as x minus negative 5. So our a now is really negative 5. It is okay. Let's set up our synthetic division. A goes up in the corner, but notice now it's a negative 5 because we were dividing by x plus 5. Our coefficients are, notice that coefficient of x cubed is just 1, and then 11, 35, 25. There are no 0 placeholders here because all terms are accounted for. Cubic, quadratic, linear, constant, all there. Always bring down that first term, that first coefficient I should say, that's a 1. Multiply, add, multiply, add, multiply, add. Our remainder is 0. Our remainder is 0. Therefore, x plus 5 is indeed a factor of that cubic. That means if I was trying to graph this cubic, I know there must be a 0 at negative 5, 0. I also know its other factor is this quadratic right here. Let's actually write that down. I know that x squared plus 6x plus 5 times x plus 5 equals our cubic. Look at what I just wrote down. I wrote down a sentence that kind of explains what we just did. We took our cubic, divided out by x plus 5, and we were left with that quadratic. Notice the 1, the 6, the 5, those are the coefficients of our quotient, which is quadratic here. So this is true. Now if I wanted to, I could keep going, and I could try to factor this quadratic if I wanted to fully factor the cubic. Is this factorable? Two numbers that multiply to 5 and add to 6? Actually, yeah, 5 and 1. So this is really x plus 5 times x plus 1. And then this, of course, is just x plus 5. Actually, there's an x plus 5 and an x plus 5. I could write that if I wanted as x plus 5 squared times x plus 1. That is equal to our original cubic. I don't know if you'd look at this cubic right away and recognize that it's fully factorable, but because we had this clue right off the bat to test x plus 5, we realized that we can fully factor it into x plus 1 times x plus 5 times x plus 5. So that's why synthetic division is great. We can see if things are factors fairly quickly, a lot faster than if we were to use long division every time. And it helps us because whatever we're left with, sometimes we can continue to factor that. Sometimes we can, sometimes we can't. In this case, we could. It's kind of neat. There you go. Good luck with synthetic division.